start streaming. There we go. All right.
All right. Hello, everybody. Welcome to another Gazebo Community meeting. I'll start by excusing Adisu because he's going to be on leave for a few months until the summer. So we'll try to do our best to replace him during these months. And having said that, let me share the screen with the agenda and the plan for today. We're going to start as usual with some announcements related with Gazebo and the ecosystem. And then we're very happy to have as a guest Benjamin Perseghetti. Thanks for volunteering. And we'll learn about what he has to say about testing with Gazebo as an excuse. So let's start with the announcements. Some of the updates, some of the progress that's been in the works for Gazebo. So some infrastructure updates. We have this tool, this table that's make it a little bit bigger. This is something that Jose has been working on. It's part of the infrastructure team to make sure that we make an efficient use of the resources when we use CI/CD, especially with Amazon and the cloud. So first thing is just to create some statistics of the usage that we do for all the different jobs, etc. And here's the summary of things that happen during the weekends on the downside, and jobs that are running during work days on the upper side. And then you can see the percentage of usage on the right-hand column. So with all this information, our goal is just to learn how to scale properly our jobs and decide how many of them, how many with GPUs, how many with Windows, how many with Linux, etc. So continue with infrastructure updates. There's an effort for moving all the Windows CI/CD from VC package to Conda, and here's another tool for testing helping develop and debugging Windows stuff. So essentially, this is a script that lets you run the same Conda job that's going to be running on the cloud, but locally. So hopefully, this will help also debugging issues on Windows. Next stop is the Zeno update. So we've been exploring the possibility of also switching or adding another middleware layer to Gazebo Transport and replace ZeroMQ or add to ZeroMQ. And Zeno is a good candidate given that ROS2 is also doing an RMW implementation in Zeno. And maybe the update here is that we developed a prototype. It's complete. So it includes PubSub, it includes services, it includes something like the graph cache. When I say it includes, it's just a prototype level, like some level of functionality related with this, but just to give us a taste of problems or how things are going. So I consider the prototype complete. There's also a design document, and everybody is invited to read it, to comment, to propose changes, to declare risks, potential problems. So please go ahead and take a look if you have some time, if you're interested in this type of things, and feel free to also contribute with your comments and your thoughts. Next thing is also some effort that we're doing for the next release for migrating from Qt 5 to Qt 6. And this is also work that Ian is taking also from Adisu. So some updates related with the entity tree has been done. Some effort related with a lot of Qt warnings that we have here in different versions of Qt have been addressed in that PR. There's another round of updates in the plugins, in the GUI plugins that we use in GSystem that require also some love. There's another PR. Some of them are in draft state, but so we're continuing this effort that is not trivial to migrate entirely for the next release in the summer. This is another interesting feature. So we are considering removing the version number from the package names. Here's the plan. You can see here like in this issue some of the, I guess, of the trade-offs that we're trying to achieve. So we're trying to reduce the churn, the some of the effort that every time that we do a release we require, a lot of bumps, a lot of new branches, a lot of changes that needs to happen every time that we do one of these releases, not only on the development side, also on the user land, especially when people is using Python, when people. So essentially we're trying to reduce that. Obviously this is always at a cost. So mainly the cost here is that we'll probably lose the ability to install Gazebo side by side, like multiple versions of Gazebo side by side. But this is something that it's getting harder and harder to do, to be honest, especially on Debian and Ubuntu, because it's the policy that they have. It's always against that. So maybe it's worth not to fight that, and maybe to leverage that and make our lives easier. So this is just an effort to do that. We decided to go ahead with this, so it's a go. And then we'll see during the next weeks and months if anything appear, any problems. But this is what we're trying to do. If anybody wants to make a comment, like I see Steve here or Ian related with Qt6 or any other changes, so feel free to interrupt me at any point. What else? So yeah, in the next feature that I'd like to mention is related with it's affecting, I'd say, the ROS Gazebo bridge. And this is something that when you're dealing with cameras, typically there's this different convention between the cameras in Gazebo and the ROS systems. So typically we have to do a transformation to convert when we are moving from Gazebo to the ROS ecosystem. And that's also confusing some people. And what we decided to do is directly embed that logic into the ROS GC bridge and also make it a little bit generic. So we're gonna be able to provide that logic almost for free if you want to enable, but at the same time we'll do it in a generic way. So you'll be able to choose a different convention if for some reason you want to. So this is something that also Ian is doing. And there's a draft PR here that's also requesting feedback in case you're interested in this type of features. Long time issue, or not an issue, but maybe like a long time source of problems or inconsistencies. Next stop is GC launch. So we decided also some time ago to deprecate GC launch in favor of using typically ROS, and part of that deprecation is to include different tutorials and explain how you should use it, and also moving the WebSocket server from GC launch to a Gazebo plugin. So there's also a migration, a PR with the migration here as well. So all the functionality should be still available. It's just that it's going to be on a different place, on a different repo, and also most of the functionality that you could achieve with GC launch is also available in just a different way. We were not using very heavily GC launch, besides a few exceptions. So, but just in case you were using it, you should know that we're going to deprecate it. Next thing is to talk about weekly contribution. This is an effort that I like to maybe give credit to Kat. So she started this initiative a few weeks ago with the idea of creating a few first-time issues in different repos that were clearly scoped and maybe more guided for people who were not super familiar with maybe the development in Gazebo, but with enough initiative to help, and it's been working. So yeah, kudos to Kat for starting this program, and kudos to everybody who we started creating these issues with. It requires some effort. It's not free. It's not cheap because you have to think about write that issue in a more descriptive way. But surprise, people then take it and use it. So thanks everybody who's contributing and helping. It's also time for Google Summer of Code. And Open Robotics was accepted as an organization one more time. And here's in this website, in this wiki, you can see some of the Gazebo projects that are up for grabs. So if you're interested in GSOC and you're looking for a project, you can take a look at this. I should say that this is not the only potential Gazebo project that you can work on. You could propose also a different project, but this is just an easier path. In any case, if you're interested in this, you should contact. You should read this wiki and understand the instructions and understand the timeline and follow the instructions to contact the potential mentors and engage with the interested people here. But you can take a taste of all the different, some of the projects, and there are also OpenRMF, ROS2 projects, so this is not exclusive to Gazebo. Well, you can have the link here. There are more things, so there's also the PMC meetings that we published also on community. You can take a look there for more detailed information of what happens weekly, but that was a summary of it. If there are no questions, we could move to our talk from Benjamin Perseghetti, our also PMC member, long-time collaborator of Gazebo. Ben is going to talk about some interesting ways, I'd say, for testing performance, hardware performance using Gazebo, and we'll see what Ben is going to show us today. Are you ready, Ben?
Yeah. I might take over the screen share if that works and share my desktop.
Of course.
All right. All right. Can you see my screen?
Yes.
All right. So this is going to be a somewhat little more interactive presentation. So I encourage anybody who feels like asking a question, interject at any time. Do not feel like you're interrupting. Luckily, there's not that many people on this call right now, so that's actually sort of perfect for this. And I'd love to have that dynamic interaction. The goal of what I've been working on recently is finding a way to look at performance changes in compute systems, whether that's your, Raspberry Pi 5 or, Jetson Orin Nano, somewhere over there. I don't know. I'm not going to dig it out. Or you name it, any system. Trying to decide what compute to use for a given system is really important, especially when you come to actually production level of design, because obviously, depending upon what your system is, if it's, for instance, like a simple basic Roomba that just needs to bounce around and have basic avoidance, slapping on a $200+ Jetson is going to be a lot of overkill. It's going to just waste power and not be particularly useful. On the other end, putting on a, Raspberry Pi Pico probably is going to maybe be potentially underkill. And you're going to suffer issues with performance and might not be able to hit the metrics that you have set up for whatever it is that, you know, the operational envelope is supposed to be. Also, it's a little bit hard sometimes to tell the differences specifically in between the capabilities of these different SBCs, mostly because a lot of the metric testing that we currently have are, you know, very basic, more pure CPU operational oriented, and don't sort of take into the whole level that truly integrated systems in robotics have. Because with robotics, you typically are going to have, you know, maybe a mixture of an MPU or GPU running simultaneously while doing some network offload, say for your DDS or whatever you might be using, ZMQ backend. All these things aren't necessarily very well represented in your typical, you know, performance benchmark that you might see online from, you name whatever favorite test suite. So a lot of this is how do we test new and emerging silicon SBCs that are either coming out or are already out in a way that it can be repeatable and also meaningful, specifically to the robotic domain. And I think Gazebo is a very good candidate because it's for driving this data into these platforms, because it's actually quite easy once you have an Ubuntu layer to install GZ transport onto any of these. And once you have that, you can actually really circumvent a lot of potential network overhead and issues due to the nature of how low overhead the ZMQ transport of, like, for instance, the image pipeline is with protobuf. So basically, for my example today, I'm going to show a little bit about how you can just directly take GZ transport, even in something as simple as a Python script, and use that for an image stream, feeding that into an MPU. I'm going to highlight sort of some tools that we create around PSUtil that allow you to see basically system load that's in ROS that you can save into a bag file. And I'm sort of going to focus on, at least right now, since this is more of a lightning talk and more interactive, just the differences in between a IMX 8MP small compute platform that runs around 5 watts or less. And
sorry to interrupt you, and just a quick question. You're not sharing slides, right?
I don't have slides. It was more dynamic than that for this one, since it's very much show as I go. A lot of stuff will be showing as we go. So
Steve was asking in the chat, and I want to make sure that you were this was your intent.
Yeah. This is going to be a show as we go. So I appreciate that, you know, question. But yes, no slides, unfortunately, this time around. But what we're basically going to do is compare this IMX 8MP, which is like a 5-watt processor, commonly used in like smart camera heads, and typically lower compute required robotic applications, very focused, smaller, low power processor, which might be really great for certain applications. We'll be testing that running an MPU on it for doing image processing. Then we're going to go up to a recently released silicon that's still in pre-production, an IMX 9.5. And that one we're not actually going to run with the NPU. And even though it has significantly higher compute on its CPU, you'll see sort of benchmarking the differences in between those different systems in that regard. So the first one we're going to start off with is I want to show how you can basically do GZ transport directly with an image pipeline with OpenCV. And of course, you can feed this into TensorFlow, but I don't really care to show you guys. I want to show you interactively. So I'm doing a Jupyter notebook, and that Jupyter notebook of this is on my desktop, so I can show interactively sort of the code and what's going on. It is what's running on the other ones, but of course I'm shelled into the other ones, so you don't get to see this. And I'm not adding the TensorFlow portion because I'm more or less, once you have the image, you can feed it into the TensorFlow pipeline, or in this case, TensorFlow Lite pipeline. So what we're doing here basically is we're pulling in GZ transport, in this case, GZ transport 13. And we're pulling in specifically GZ messages for an image, and I'm putting in as GZ image since there's sometimes namespace collision. A lot of things like TensorFlow like you to use PIL, Python image library, and PIL also has image in it. So, you know, to avoid collisions, you know, I'm renaming this to GZ image. So the first thing we're basically doing is we're just setting up a GZ node. And we're setting up a subscriber. So pretty straightforward. And we get a callback and a message type of that GZ image, like we just showed right there. We take from that callback, we take out the message width, the message height. We use NumPy to basically grab from buffer all these bytes that are being sent in that protobuf message. And we're making some assumptions. You could technically test to see if it was R8, G8, V8, or whatever type. We're just going to, we already know in advance that, you know, it's 8-bit image, so we're going with this. Basically, what we want to do for leveraging TF is we want to create a sequence number associated that already comes from the image. But we want to match through TF that sequence number back to the actual image because, you know, inference takes a little bit of time. You don't know what rate things are happening at necessarily, or, you know, network load. So this is just showing an example of grabbing that sequence key from the header data from Gazebo camera, and then basically naming a window title. This is a simulation of a OB5645 camera. And basically driving this into just a basic IM show image frame, re-updating it. And this is basically just showing you, you know, what you can basically get out. Now, one thing you will notice, this coloring is absolutely horrible. I don't think I'd want to eat a meal that's blue colored, personally. But, and also it's very small resolution intentionally because it's already pired down to the low setting because that makes your inference a little bit easier than having to run that. And basically, this is just giving you that image pipeline, as you can already see coming here from that simulator, updating that sequence number. I've had this run in the background for a little while right now. And that's more or less just your view off the front end of this, right? And I will make this thing drive around a little bit. Second here. And power on my joystick. And cool. Let's restart this one. And get that going right here. Okay. And initialize the joystick. All right. So yeah, basically that's the gist of this right here. I'm going to actually also restart the simulator so we can get an earlier sequence queue here going through. But that's most of what that's useful for, is just showing how you would subscribe to that in Python. So that way you can throw it through a different, which typically most AI ML typically prefers Python backends, it seems. The other thing right here is just a basic actuator joystick subscriber publishing to actuators, just so I don't have to run any POSIX based anything. So, you know, as you can see, you can drive around in here. It updates the images as I'm driving around, all these nice blue colored tinted things, since it's using OpenCV's encoding. So yeah, there's the gist of that. Let's go here. And now I'm going to show you on an actual system. Start clear outputs. Okay. On an actual end system, for instance, this right here is the IMX 8MP NavQ. And what we have running right now currently on it is this ROS2 PSUtil. And so this basically grabs all of the details of your system, your network, your I/O wait time of your processor. Like, it pretty much covers everything. Your temperature, your all the sub details of your memory and hard drive, all of that, it saves out. So we have this running in the background, and what this more or less allows us to do is look at load averages on the systems, what we care about. And yes, I could use filters in ROS to look at this, but I'm just using grep because I'm feeling particularly lazy. So as you can see, our load average is really low here, right? A nice low load average. And basically all these things right here are convenient for looking at what's going on with your system, specifically recording a bag file with all these details in it. And there is a lot of details. Like, you can look at system idle, IO wait, all these things that you'd want to look at, graph them if you really felt like it, frequencies and everything else, and as well as time since boot. So let's see here. What I'm going to do next is basically run this GZ NPU script that I have. And what this does is it pulls in over the network that I have directly connected point to point, the GZ image, like what we saw that was in that previous Python script, but instead it's pulling it directly with GZ transport into a ROS node that will output that TF light topic. And then we're going to run a debug on the desktop side. Traditionally, you wouldn't really do this if you're performance testing because you want the least amount of your network, in my opinion. Basically we'll see what the actual load is there in RQT debug from that. So this is launching that NPU right now, and a lot of times the NPU takes a while to quote unquote warm up. So there you go. It's not giving an accurate millisecond time, but that's fine on the warm up. So this right now is running this NPU. It's getting images. And if we were to go over here with RQT, you can see it's seeing something in the corner. Let's move this around here. So you can see that it's doing some inference and, seeing different fun things as it goes around here. Let's go here. Person. Yay. Let's see if it can recognize banana. Okay. It thinks it's a bird. So that's, is what it is. But basically, I think, oh, there we go. Banana. Just had to get closer. Basically, you can get the idea. It's running inference on here, and we can look at the overall system load when it's running inference. And you'll see that it went up, right? Load average definitely went up. So we're definitely running something. Not terrible, but definitely went up. And to that point, you could also look at, for instance, HTOP, which basically shows you the very similar thing. So if we go here and we run instead HTOP, okay, you'll see that we have some load, but pretty much it's mostly all just going through the NPU. So our load is very minimal, which is quite impressive. So next thing I'm going to do is I'm going to show a comparison with that with our other compute system. So let me unplug and power this off. Make sure that this thing's still powered on. It didn't go into like sleep mode. Okay. As a matter of fact, I'm going to unpower this guy just to play it safe. And I need to switch over my network here. Plug into the other one. All right. Plugged into this one. And I'm going to be lazy here. The last thing I'll show at the end of this also is how to set up these so that GZ transport talks, properly across. Note that these are all running Ubuntu 24.04, so it is possible to for those who might be Jetson people to run native 24.04 on ARM outside of a Raspberry Pi. All right. So the next thing we're going to do here is we're going to run this GZ NPU. First, though, I'm going to make sure that I have my network connection set up properly here. Okay. And let's see here. Basically, I'm getting rid of the systemd network settings that normally you would want, but in this case we don't. Specifically because let's see here. All right, that looks good. And now we can run the NPU, except actually we don't want to run a bridge. 1 second. Okay, so this one's going to be defaulting back to a CPU delegate instead, and it's not actually going to be running the primary NPU. And then come over here, for instance, and you can immediately already see that we're hitting off, significant amount on at least 2 of our cores, if not 3 of our cores. And this is a fairly reduced down image. If you, for instance, put this in at 640 by 480, the NPU still just crushes it completely. And the load on this one even goes up higher. So here's an example where you can see the load differences between the two. You still get the inference going across, of course, in between those ones, where now it's coming from this other system, but it's coming instead from, of course, the CPU, which is adding significantly, which you can't see right there, more load to your system, which then, affects things like, if you're running a navigation stack or anything else like that, that typically targets your CPU more. And as you can see, the load average up here is already over 1 on one of the setups. And the way the load average works, it's like most recent 5 and like 15 minutes averaging. So this is the one that sort of, that first value is the one that matters the most. So yeah, significantly higher load in comparison. And, one of the things that's beneficial about this as well is testing for regression performance-wise in your software as you have things change upstream library-wise. In this example, I'm not going super heavy into the raw side and showing examples of running, say, a navigation stack, but eventually our plan is to create a fixed example where it's going to run through a set of waypoints through, Gazebo Sim being fed offboard, and then that is basically going to record a bag file that you can integrate the load over time during that, as well as the time of completion as it tries to figure out sort of that dynamic path planning, and that way give a little more of a meaningful metric to how well something is going to perform as navigational robot. The other thing I'll show as well is basically how to set up this. So a lot of times people will have issues using network connected devices for sort of hardware in the loop testing with simulators. And actually, I think I had a call recently with Carlos on it. He was gracious enough to hop on and sort of describing sort of some future development that I think we're planning to do in that realm. And specifically, right now, if you want to set your networks to communicate with each other, you have to have 2 things. You have to basically have a GZ partition set up, which basically gives sort of this namespacing of, hey, am I supposed to talk with you or am I not supposed to talk with you? And that needs to be matching on both systems. The other one is that you need to set the GZ IP, because otherwise it can be looking for the TCP portion of the ZMPU on a wrong NIC, or basically network device, right? And currently we set it by setting the GZ IP, But if you're joining, for instance, a wireless network or anything else, IPs can be dynamically, of course, partitioned. And, one day when you turn it on to do your hardware in the loop, you might just be in your head going, oh no, everything's broken. And reality, your network IP changed. So I think the goal is eventually to set that to allowing for a name specified NIC instead, a little bit sort of like what you see in a Cyclone DDS XML file. So for instance, if you wanted to look at that, let's see here. For instance, I'm using this END0 network interface name, which is the device specifically right here that I forcefully set up connection-wise in between the two. And what this is going to basically allow us to do, at least in theory, is allow you to, no matter what network you're connected to and what its provisioning is, still have a reliable connection in between your GZ server, what's running the actual GZ instance, and then your hardware in the loop system, wherever that may be. For right now, we at least have a script which I can share if anybody wants to reach out. Very basic Python script that basically looks at all of your network names that you have on your computer, sees if it has an AFI net, so IPv4, adds a completer to let you know which ones they are and also tab complete them, and then basically finds the IP address of it and then sets that in your bash RC, so that way you can basically reset it. And it will also overwrite any old ones. So for instance, if I run it on this, right now I'm on the END0, but previously I was on ENP2P0S8F0, which is a 2R automotive Ethernet bus. When I was wanting to test basically sending video streams over 100 megabit per second 2R automotive Ethernet. So, you can type in EN tab, you see that, type in P, whatever. You can run that. It's asking me if I want to change it. In this case, I'm not going to change it, but there's the IP address that would be if it were to change it. And here's my current GZ IP address of what I have set. I don't want to change it. That will update it for you. So it's a nice little convenient script that if you want to play it safe, you can always run in advance. So hopefully I haven't bored everybody to death yet too much. But yeah, if anybody has any questions or any thoughts on any of this, I'd definitely enjoy any input that might be had in that regard.
Thanks, Ben. That was nice. Thanks a lot for the presentation and presentation and plus the demos and your thoughts. Questions for Ben?
And if anybody has interest in thinking about what might be good robotic performance tests to then be able to compare across things, like compare a Raspberry Pi doing a NAV2 stack with, you name it, a variety of things. I would definitely be interested in people's input on that, because I do think that's a valuable metric comparison, because a lot of people, right now approach it from a purely generalized theoretical perspective of like, well, the Jetson's better than a RPi 5 and a RPi 5 is better than a whatever or so
it's also like when you started talking about this benchmarks, this is something that I shared with some people very recently. Like every time that, if you see these times, right, like every time that there are NVIDIA or AMD is about to release a new card or maybe a new CPU, there's like like 100 or thousands YouTubers or articles on the net benchmarking that for games, for productivity, for so there's like a wide set of benchmarks many different things, right? Like all maybe like 100 different games, maybe like rendering, maybe like I don't know.
Blender classroom benchmark, right? Where they run and see how fast you can generate that, or Puget benchmark, or
Yeah, doing ray tracing, non-ray tracing, doing
yeah,
running this game at 4K and or not, or so. In general, we have a sense, right, of how what we think it might be a good CPU, what we think it might be a good GPU, what we think it might be a good card for running what micro ROS or not. But yeah, it would be very nice to have this set of benchmarks. Probably a single benchmark is going to be tough, but at least a collection of maybe a wiki where we can find all the different benchmarks, and then okay, every time that you need to scale or you need to decide, okay, which CPU I'm going to run on my desktop, which GPU I'm going to run on my desktop if I'm going to be running simulations, or if I'm going to be running I don't know, NAP2 with ROS2, or if I need to choose like I guess an embedded card for, I don't know, for my robot. Yeah, that would be great, to be honest.
yeah, and I think it's also interesting because you do get different bottlenecks, specifically when you're in the robotics realm, right? Your bottleneck might not be the tensor cores on your Jetson, right? So maybe all those really cool benchmarks don't matter as much as you think they do, or maybe they matter a lot. Maybe you really do need to do some pretty hard inferencing, and that would otherwise be offloaded on your CPU, and then you can't run as large of a collision checker in nav2. So I do think that anybody who wants to sort of possibly work together on trying to figure out what sort of a good test workbench would be like, I think that would sort of be cool to try to have, because for me it's not inherent, and I work with all these systems all the time. I just got another little, I think I've opened this one out of its box yet. Here you go, another little Jetson Orin Nano developers kit. And you don't really, it's sometimes hard to determine the value of the beneficial differences in between, say, like a Nano and, I don't know, previous generation NX. Like, is that, which one's more valuable to be using in robotics? It's hard to tell because it covers so many different domains. So yeah, if anybody does have any thoughts on that, feel free to reach out to me. I'm on Discord, and also, whatever, on GitHub, I guess.
We have a question from Steve.
Yeah.
Yeah, thanks, Ben. Nice presentation. I liked seeing the Jupyter notebooks, and I just wondered how do you find the usability of our current sets of Python bindings, and how does it compare to using Python with ROS? And
yeah,
do you have any feature wish requests, or anything that you feel could be better?
That's a good question. So let me reload this one back up. I think one of the things that was interesting to me about this was a little bit about how you access the messages. This was not entirely natural. I struggled with this. I'm not gonna lie. I initially struggled with this, and I had to sort of scrunch around and be like, okay, where's this done? To me, I would think it might be like, from GZ Messages 10, import image PB2 or something, not, from this import image. And that was sort of one of those like head scratchers that took me. That was the only thing I think I really was a head scratcher for a little bit. That took me a little more time. I think overall the usability it has been pretty great and straightforward and easy. I think, maybe the documentation around this, and then also, depending upon how much you're familiar with protobuf versus not, some people might think that you'd have something like this, right? message.height, and it's like a function you're calling like a get kind of type thing, get the height. But it's not, right? It's just .height, which is data structurized, which is fine, right? I guess that makes sense. It just depends, once again, how familiar you are with using protobuf and some of your assumptions around it and some of the bindings associated with that. If we go to GitHub, for instance, Gazebo Sim, GZ messages, and we go here and look at, for instance, this, if I'm just somebody who's trying to go at this randomly and not really knowing a lot about it, what am I looking for here? I'm looking for image just to compare across. My source of truth would be, for instance, going here, right? And so, okay, I guess the message says image. I'll go ahead and grab image. I guess that makes a certain amount of sense. I don't think I actually even tried seeing if I can grab pixel format type. That was my, next one that I was going to try to more or less integrate so it could handle, a wider variety in that little script, so I could test out some different ones, but I didn't get to that point yet. I don't know if enums are actually correctly bound to pass through. So there's some questions sort of still there, I guess. But overall, I think it was pretty good experience.
Yeah. Do you have is there any version of this that you have posted publicly as open source?
So all of the TF related stuff that I have is publicly available. I have a set of TF messages and a way to load inference engines and stuff like that. Where is that at? Let's just go here, reopen this up. So yeah, some of this stuff right here I do have. I haven't touched it in a hot second, but if I go here, let's see here. Debug image TF, so that's where you're applying the model returns. Very simple, straightforward script. This is NXP TF Lite, but it's not inherently NXP. It's just that I defaulted the models that were compiled for the NXP NPU, right? So you could just put a different model in, and that would work as well. And once again, this is a very straightforward, it outputs directly onto these TF Lite messages, which is basically the TF Lite message is as straightforward as it gets. What's the inference from an object found? It's a label, it's a score, and it's a bounding box. And it's, TF Lite message wraps that with inference time, the actual inference, camera info, so you can match it back up, of course, and then its own headers. Yeah, so those are already open. The PSUtil related stuff is also open, and these are all things I do plan to have as binary releases at some point when I get time. So PSUtil, is here, and people are more than welcome to, do whatever they feel like, or whatnot, or contribute or make suggestions of changes. But here's the PSUtil that I was showing that you can run. It has a lot of options to choose selectively what you're actually recording as well, into a bag file. And actually using this was one of the ways that I found that the governor was not set to performance mode for the CPU on one of the systems, because one of the fuses wasn't set properly on reboot. So things like that you probably would not know, and you're like, well, why is it setting itself down? Why is it downclocking? I want this thing running hot. Like, I don't want to think about when it wants to slow down. I want it to just go. So it's a useful tool if you do tend to work on deployable robotic systems, or things of that nature, to really get an idea of what your whole system's looking like and working. The only thing I would say that I would like to try to do more of is probably trying to get an easier way around how we handle GZ transport setup, right? Because since all of these things, and this was a little like what I was talking about with Carlos, all these things are sort of hidden, right? Like I can't, I can do like GZ topic. Okay, you have to like make it verbose mode, and then you can type like information on it, and like -e, I don't know what's one of them, clock. Hopefully that still exists. I don't know if I closed all that down or not. So okay, yeah, I can see that it must be using this as its GZIP, right? But that doesn't really tell me anything else about my system. Like what is it using for the multicast? Is it using the same NIC? Is it just choosing its own? What is it using for multicast discovery, I should say? What is it using for its GZ partition? There's no real good way to know that, right? And I can't even type GZ partition in here. Like, maybe I manually set it, forced it, but right. So, yeah, I wouldn't know what this is set to unless if I physically set it. Now, in this case, it does default to, your host name : username at the time. Okay, that's good to know, but it's not inherently easy to see. So I think an expansion of maybe either GZ topic or even another functional set like GZ transport and allow for, instead of GZ topic, and allow for people to configure and keeping track of what those things are so they can be then set easily from a CLI, I think is valuable, because setting environment variables isn't particularly fun. And to that point, I think GZ transport, where's the, maybe it's in here, under examples, and I think it's under maybe relay. There's a README somewhere. I don't know. But yeah, basically the environment variables, wherever they're listed at here, tutorials, here we go, relay. The environment variables for setting these up are not necessarily intuitive, right? When do I need to set a GZIP? What should I set it to? How do I, do this? While this will work in some cases, it won't work in all topologies, and you won't have a clue why it's not working unless you set it. And then when you do set it, you don't necessarily have a good idea necessarily, because you don't get dynamic introspection. So yeah, I don't know. That's pretty much it from my side.
Yeah, that sounds good. Maybe open a feature request and we can continue on that. I have to drop shortly.
No worries. Yeah, I actually ended up going way longer than I expected to. So
Yeah, thanks a lot. Thanks
lack
again.
of sleep is amazing for rambling.
For the talk, for your thoughts, and I think we ran out of time for more questions and comments. But thanks everybody. See you next month. That's up.
All right. Thanks.